Hi everybody, this is lesson 18, more problems on area and circumference. So our essential question is how can we solve more complex problems on area and circumference of circles? So these problems are still going to be with area and circumference, but they're going to be a little more complex. There's going to be something else to it, or maybe it's part of a circle, or maybe it's two shapes put together. In fact, we'll be doing this for the next couple lessons as well. So we're actually going to skip the opening exercise, and I'd like for you to turn to page 137. Well, your book is open to 137, but you can cross off the rest of page 136 after you write down the essential question. Okay, for example 1, we're going to find the area of the following semicircle. Now, we don't have, per se, a formula exactly for a semicircle. You may have written it down. It's up to you how many formulas you'd like to collect, on your inside cover where you've been tracking them. But for me, I know that the area of a circle is pi r squared. So before I kind of get confused as to how to do this, I want to at least write a formula down. Okay, that's the area of a circle. And this is a semicircle, which is half of a circle. Okay, so with that, I promise it is that easy to make up a formula for this. You are literally just taking this formula and you are going to divide it by 2. That's how you find half of something. So you can write it like this. Area equals 1/2 of pi r squared. You can also write it like this. Area equals pi r squared, all divided by 2. Either way will get you the same answer. Half of something is the same as dividing by 2. All we need to do now is plug in the radius. So what is the radius for this semicircle? And if you're having trouble, what I like to do is kind of finish the circle. It doesn't have to be perfect, obviously, because that one is a little lopsided, but you can still see what it would look like if it was the whole thing. So actually, that's the diameter. We need to find the radius. Remember the relationship from the diameter to the radius? Right, the radius is half. So 7 centimeters is our radius, since our diameter was 14 centimeters. Okay, now we just go over here and we plug in 7. By the way, sorry, hopefully this isn't confusing, but they're saying to use 22/7 for pi. You can use the pi button or 3.14. I kind of want to see a final number. I'm going to use 3.14. And remember, they're all approximations, so sometimes our answers are going to be a little close to one another. Okay, so that would be 3.14 times r squared, which we said was 7. Okay, so let's pause right there. We can see that this is the area of the whole circle, pi times radius squared, and then we're going to take half of it. So first, let's find the area of the circle. With your calculator, do 3.14 times 7 squared. Okay, remember that's 7 times 7, not 7 times 2. And did you get 153.86 or about that? It's okay if you're off by a little bit because, like I said, sometimes we use the pi button, sometimes 22/7. I'm using 3.14. Okay, so the area of the semicircle or half circle is going to be half of that. So now you can just take that number and divide it by 2, and our area is 76.93 centimeters squared because it's area. Don't forget to have the correct label. Okay, if that was half a circle and we divide it by 2, what's going on in the next example? What is the area of the quarter circle? So we can say 1/4 or divide by 4. So I want you to try writing a formula. There's two ways you could write it, and either way would be correct. Okay, you can say pi r squared all divided by 4, or you can say 1/4 of pi r squared. Like I said, either way is correct. You can try it both ways if you want to see. I'm going to go ahead and just do the first one so you can see how it looks like with a fraction bar. Okay, did they give us the radius? Yes, in this case they gave us the radius. We're not going to need the diameter for this, but it's just a good habit to form to write the radius and the diameter. Okay, now with our formula, we're going to plug in. Let's use 3.14. We know the radius is 6 squared. And then we're going to divide that by 4. So go ahead and get 3.14 times 6 squared. Okay, and did you get 113.04? Don't forget we have to divide that by 4. Because we're not using this whole circle. So if I made it like this, you can see we're only finding 1/4 of that. Okay, we're not finding the whole thing. So if you need to kind of like draw that original circle so you can see it, that might help. And they told you quarter circle in the problem. Okay, so the area is approximately 28.26 centimeters squared. And I'm glad that we actually paid attention to that. When we find an area, we're going to use those squiggle lines. This means it's about. Okay, once I plug in 3.14, I'm saying that it's about that much. Okay, because we know that pi isn't exactly 3.14, it's about 3.14. Okay, so those are like, different sizes. Now let's say we had a circle and it was split into thirds. You could do the same process, but just use a third or divide by 3. So this was half and this was a fourth. This is just another example of the fact that you're not going to have a formula for all these different kinds of circles, but you can still come up with the formula because you know what the area of a circle is, pi r squared. Okay, Marjorie is designing a new set of placemats, and she sketched this drawing on graph paper. The diagram represents the area consisting of a rectangle and 2 semicircles. Well, guys, what does 2 semicircles mean? It's 1 circle. Okay? Depending on the question, we might be able to use that to our advantage to make this a little more efficient. The other thing that we have to pay attention to is each square on the grid measures 4 inches in length. So they didn't tell us the radius, they didn't tell us the diameter, they said each square measures 4 inches in length. So if this is 4, this is 4, this is 4, do you see where this is coming from? It might be helpful to kind of label them all the way around. And that kind of helps you see the length, the width. It even helps us see the radius and the diameter. Okay, so let's find the area of the entire placemat. So the entire placemat is going to be this rectangle that I've got here in purple. So let's write this. Let's write 1 rectangle. And this is half a circle and this is half a circle. So what does that make? 1 circle. So we have 1 rectangle and 1 circle. And that's it, because it's area, I'm covering it. So I'm not trying to find the outside of it. I don't need to know, the inside. These are just all put together one seamless thing here. So I'm going to kind of get rid of those colors so we can see it a little better. Let's go ahead and write the formula for those 2 things. A rectangle is base times height, or you can do length times width. And a circle is pi r squared. Okay, so in purple there I have the rectangle formula, and in green I have the circle formula. Now we need to figure out what are these base and height and the radius. So I need to know base, I need to know height, and I need to know the radius. How are we going to figure those things out? Some of you might have already figured it out, but if you trace around the rectangle, you can see the length and width, or the base and height, are going to be 2 of these sides. We've got 12, because 4 times 3 would be one of the sides, and then 8, because we have 4 plus 4 is another side. What is the radius of the circle? And again, I'm going to erase all this so that you can kind of see it a little cleaner. If this is half a circle, this would be the other half of the circle. What is the radius? In fact, it could be from the center to the edge of any of these. And they tell us in the problem that each one of those is 4. So the radius is 4 inches. So now we plug in 3.14 times 4 squared. Okay, so now we're going to find the area, which is going to be 96 for the rectangle, and then again go ahead and solve the circle area, and you should get 50.24. At any time that you get something wrong, you can always go back and try it again or try to figure out what your mistake is. Don't keep going. You can pause it, try to fix it, and then it'll make more sense when you follow along. Okay, so the area of the whole thing is approximately 146.24 inches squared. Okay, on page 138, we want to know if she makes 6 of them, how much fabric will she need? And it says, don't worry about the waste. Okay, so yeah, we would have to do a couple other steps if we worried about that. We're just going to go ahead and figure out 6 times 146.24. So she needs approximately, and of course you can pause it and try it to see if you get it right. 877.44 square inches. Okay, where this one gets interesting is now she wants to sew contrasting band of material around the edge of the placemats. Underline that, around the edge. How much band material will she need? So basically, we are going around the outside, and that is perimeter. Okay, I have to go back to the previous page. You're going to want to look at it too. Around the outside, watch as I trace. Around the outside, we've got this length right here. We've got half of a circle. Then we have this length right here. And then we have half of a circle. So if you can picture that the half of the circle and the other half of the circle would be one circle, and then we have 2 of the lengths. 2 lengths. Okay, so now we're going to bring that kind of onto the next page there. So it's going to be 1 circle plus 2 lengths. Okay, and the word that we use for the distance around a circle is circumference. So we can do circumference. Excuse me. And then we're going to use 2 of the lengths. So we can just say 2L. Okay, so pi we can say is 3.14 times diameter. What is the diameter of this one? It's this right here, which we know is 4 and 4. So the diameter is 8. And then 2 of the lengths. So figure out what the lengths are. I know you can do that. Did you get 12? Okay, now you can do 3.14 times 8 and 2 times 12. They're actually pretty similar numbers. 25.12 plus 24. So she needs about 49.12 inches to put border around one placemat. Okay. All right, that's actually going to be a wrap on this video. So we just did 3 examples. The last example was a little more involved. And basically what this lesson does is it shows you how to take some different looking objects but still use those same formulas that we've been using to try to tackle some of these odd shapes that involve circles. Okay, so that is a wrap on lesson 18.